Hello there, and a big warm welcome to this BlueVen session, putting predictive analytics to use for delivering better customer experiences. So today we're going to be looking at the prerequisites for a successful predictive analytics strategy, and we're going to run through some predictive models that will help you to increase purchase profitability. So today we've got Matt Diamond, who's one of our consultants at BlueVen. He'll be running the session for us. And the session should last about 30 minutes or so plus questions. So make sure you send over those questions to us and we'll get to them at the end. Any that we don't manage to cover will be answered offline. Okay, so Matt, thank you very much for joining us today. Are you ready to jump in? I know you've got a lot to get through over the next 30 minutes.
Absolutely. It's a pleasure to be here, Jen. So as Jen said, hi everyone, my name's Matt and I'm going to be taking today's webinar. I'm a member of the consultancy team here at BlueVen. And today I'm going to be talking through some of the predictive analytics examples we have today and exploring some of the options that we as marketers have to utilize predictive analytics within our day-to-day activities. So I wanted to begin today by posing three questions. Why do we use predictive analytics? What do they help us achieve? And what type of predictive analytics do we have at our disposal? And I hope to answer each of these as we go through today's webinar. But before we address each of these questions in turn, I wanted to begin with a famous, yet highly relevant quote from Benjamin Franklin. By failing to prepare, you, or in this case we, are preparing to fail. And as I'm sure many of us on the webinar today know, before we can execute reliable predictive analytics using our own customer data, there are some key preparation steps that need to be undertaken first. So firstly, we're going to talk about personally identifiable information and cleansing of that personally identifiable information. This isn't only good practice, but it ensures improved match rates when matching customers together and aggregating the data. This usually involves running data through postcode address files, and in many cases, matching to third-party data sets from third-party providers. When we come on to standardization, this ensures that data of the same type from multiple sources is consistent. So for example, mail, 0, and M are all standardized to read mail. This helps to remove any misinterpretations of our data as we start to use it right across our marketing ecosystem. When we move on to validation and verification, here we are ensuring that data is in the correct format. For example, dates are actually dates and they're not just free text, and that the data is valid. For example, verifying that product codes all exist against a known lookup table and ensuring that they have not been incorrectly entered manually or loaded into the system. And when we start to look at customer matching, we also start to consider things such as identity resolution. And this is where this is all done to ensure that each customer is only existing once within the database. And this is particularly relevant where we are bringing together multiple source systems in multiple ways across the different elements of the online and offline areas of the business. When we start to discuss aggregation, this is where we are actually looking at making sure data is correctly rolled up with business rules in place to determine how to deal with clashes. For example, multiple phone numbers, multiple dates of birth, for example. What we typically see is that you can use the most recent value that has been added to the particular database, or you can go a step deeper and specify trust and survivorship rules to ensure that you're able to utilize the most reliable data according to the different sources that are being ingested. And when we look at data enhancement, this is where those third parties come in. And this is about understanding the gaps in your data, whether that's data that's missing because it's not been gathered through source systems, or those variables are not something customers would potentially share, but can be purchased from third-party providers. A couple of easy examples of things like age, income, and lifestyle. But there are a whole host of socio-demographic or firmographic elements that can be added to your particular database as required. And finally, we come down to variable definitions. And this is where we're ensuring that the variables meet the needs for analysis. So, for example, if you have date of birth in your database, you may consider creating more suitable discrete variables, such as age, year of birth, month of birth, and age band to aid further analytical use cases within your marketing ecosystem. So, as part of the preparation process, and like I find with most things in life, data is not always straightforward. But here are some of the top issues that we come across at BlueVenn when looking at the preparation of customer data. The first being the difference between operational and marketing addresses. Just because a customer's registered address is typically their home, it doesn't mean that this address is correct for every interaction. How many of us have purchased from an online retailer such as Amazon and have had those items delivered to our place of work or to another address rather than to our own home? And on many occasions, myself and my colleagues have also seen delivery instructions left within particular address data. For example, please leave the package at the garden gate. Or directions such as, if you pop down the alley, the post box is round the side of the garage. The second thing to consider then in this case is internal transactions. Now, these can be hangovers from testing, training, or other internal processes that mean transactions are recorded against dummy records. And for example, in one customer's data, we found over £10 million in revenue recorded against an internal cost code that had been used for training, but wasn't being excluded from particular pieces of analytical work, therefore obviously skewing the results. When we're starting to look at things such as returned goods, these are sometimes managed through different systems and lots of different ways. And for example, sometimes they can have positive values with a return flag. So if I buy 9 items and return 6, this could be recorded as 9 items, 15 items, or a net purchase of 3 items. So being clear on how returns are tracked and presented is key to data accuracy. Now, system switchovers as well are something to consider. So moving data from one system into a new system, as we all know, it doesn't always go smoothly. Business decisions can be made that corrupt the meaning of data, or the person or people who've managed that switchover could no longer be present in the business. And this can lead to an inherent loss of understanding of that historical data. And finally, we come forward to defining who the customer actually is within our data. And this has 2 elements as I see it. So firstly is, do you have leads, opportunities, or prospects in your customer data? If you do, then the way you classify these can potentially alter outcomes and lead to inevitable inaccuracies. And also for customers who have historically purchased from your particular company, but who are now lapsed, you should consider suppressing gonaways and suppressing bereavement registers to ensure that data is up to date, accurate, and compliant. So now our data is in order, it's fully prepared. So let's look at some of the different types of predictive analytics that we can utilize within marketing and some of their particular use cases. So beginning with segmentation, as its name suggests, this deals with dividing your customer base into groups or classifications. Now each segment groups customers with similar characteristics. An obvious example of this are the classifications that data providers have built to describe the population. Axiom have Personix, Experian have Mosaic, and CACI have ACOR. And these individual classifications are built through analysis and modeling of data that has been collected on individuals. And you can see from the Axiom classification on the screen that they have used age, lifestyle, affluence, and digital footprint to form 55 distinct different customer segments. And these segment classifications have a 2-fold purpose. One is delivering the classification model to actually segment the data. And in this case, this is visualized by the 55 different circles we have. But the second serves to describe the population and your customer base to provide context when working with the data and enabling meaningful discussions to take place across the business. Now, if we take the Axiom segment Born Digital, for example, this is circle number 1 here. This segment describes young adults with a low income, many of whom are still living at home, who regularly use the internet and have digital and social media as their preferred channel. And if we compare that with segment 43, mortgage-free and jet set, these are older people with a good income whose children are no longer living at home, and they exhibit less internet and digital channel usage. Now, both of these are tangible descriptions that can be readily understood by everyone, rather than referring to Axiom segment 1 or Axiom segment 43, for example. Clearly, lots of time and effort has gone into actually building up these individual portraits, and these are a great goal to aim for when actually looking to understand and classify your own first-party customer data. At this point, I just wanted to point out one other thing as well, is that this type of segmentation, the way I've described it here, can also be known as descriptive modeling as well as segmentation. Now, recency, frequency, and value, commonly shortened to RFV or RFM, is one of the most common and widely employed uses of predictive analytics. The approach here is to segment your customer base in a similar way to the way Axiom and other third-party providers have done. But this is based upon the individual customer's transactional behavior and how that can identify retention, upsell and cross-sell opportunities that in turn can help to prevent customer churn and reinforce customer loyalty. So with BlueVenn, the parameters are configurable and are based on, as the name suggests, recency. This is the last purchase date, and in this example has been split into 3 bands defined as purchased within the last 3 months, within the last 6 months, and finally customers who have purchased 6 months or a longer time period ago. When we move on to frequency, this is the number of purchases over a given period, and in this example is split into equal bands of customers. So there are around 100,000 customers in each group, and the bound boundaries can therefore be dynamic depending upon the inclusion. And finally, looking at value, this is where customer spend over a given period is used to split the customer groups into bands of equal size, 100,000 as well in this particular case. Now, BlueVenn's standard RFV or RFM model is based on a 3x3x3 classification. And this creates a matrix, as you can see on screen here, of high to low values of 27 distinct granular segments. But based on our experience, we further reduced these down to make a more manageable 6 segments that are more suited to different customer marketing programs. And you can see here, now that I've added in the different words, you can see how we've actually grouped 27 segments into those 6 aggregated segments. So for our devotees, these are our top customers in each classification with a high level of recency, frequency and value. Our welcomes, who are new to us, and as such they've only made a few low value or one slightly higher value purchase. Our reactivates, for example, have lower frequency and lower recency, but do add value. And finally, our no actions offer little value and have a very low level of engagement, if any. Now, the reasoning behind BlueVenn's aggregation of RFV segments is to ensure that each segment is closely aligned with an appropriate marketing strategy. So, for example, here, you could offer rewards to your devotees, upsell high-value products to your loyals, cross-sell other products to your growing customer segment, deliver a welcome campaign to your newer customers, help retain customers by making limited time offers, make personalized automated offers on your website that do not require marketing spend to that particular no action segment. And for the eagle-eyed amongst you, you'll also notice that there is a seventh segment or remainder segment. And this is effectively your lapsed segment. You may wish to reach out to them or do nothing in line with your strategy or preference at a particular point in time. Now, with BlueVenn's built-in recency frequency value dashboard, users are able to see a visual representation of the entire customer base in line with their RFV segment. So in the top left, we have a comparison of the previous versus current RFV distribution. The top right gives us a visualization of the relative size of each of the current segments represented by the colored circles. And at the bottom, this particular trace over time shows us how our customers are moving between segments and how segment size is evolving. If we just jump back to the matrix on the top left, what we can see here is that previous segments are in rows, the current values are in the columns, and the black diagonal shows where the segments haven't changed month on month. And the green section is where customers have moved into a higher segment, and the yellow where customers have moved down into a lower segment. So you can see here that 834 in the row devotees have now moved down into the loyal segment column. So I'm now going to move on to discuss a recent addition to the BlueVenn platform in the form of cluster modeling. So with the rise in the popularity of the R modeling language, BlueVenn have chosen to embed R within the platform, thus enabling marketers to harness the power of predictive analytics and predictive modeling, and do so through a wizard interface, thus removing the need for them to actually have to rely on learning a complex statistical language or heavily lean on a team of data scientists. Within the modeling wizard that we can see on the screen here, starting at the top left, we can select the table level for our analysis. So in this case, we're conducting our analysis at a sales level. And after defining our modeling method in the top right, in this case, K-prototypes clustering, we can then move on to utilizing our own empirical knowledge of our data to select the most appropriate variables to include when building this specific cluster model. We can also limit the data at the bottom here, or limit what can be referred to as the modeling universe exposed to the model by setting the particular model query at the base of the wizard. And this is commonly used to exclude data that's not relevant in the construction of the model. A good example here would be if I was building a regression model and I wanted to model on customer purchase behavior, I would potentially want to exclude all customers that have never made a purchase of that particular product, or potentially have never made a purchase in that category or at all. So once the model here for this cluster model has actually been constructed, we can then evaluate our model to identify the optimum number of clusters to build by looking at the elbow curve that is surfaced as part of the wizard. And what we're looking for here is the point at which the addition of more clusters starts to have little to no effect on the model's ability to include new data. And as you can see here, this is visually represented by a flattening off of that elbow curve. Once we've chosen the number of segments to create, we can then actually move on to training the model. And it's this training process that produces the polynomial form, which defines each customer's membership of a particular cluster. Once produced and applied to the subset of data that has been used to create the model, the wizard then presents a summary of the proportion of customers in each segment, alongside the most significant variables informing their membership of that cluster. We now move on to scoring. This is where we're actually scoring our model and allowing the model to be rolled out and applied to the entire customer base. And by presenting these particular scoring details, users are able to actually understand the model as it is applied to the customer base and visualize the proportional relationship between the number of customers that have been enrolled within each segment. If we look at actually using a cluster model, and unlike some other types of models, clusters are more analytically focused in their outputs. Now, one of the key benefits here of their use is their ability to actually compare variables and uncover patterns and commonalities that the human eye, no matter how trained and how brilliant its skill level, would miss. And this is actually allowing for the uncovering of new, previously undiscovered segments that can then be used within your marketing activities. My final example today is going to be focused around regression modeling. Now, which, like clustering, has very much long been the domain of the statistician and latterly the data scientist, and has required extensive knowledge of tools such as SAS and SPSS. Now here, BlueVenn uses a similar wizard to the one that we explored when we looked at the creation of cluster models. But as we will see, the stages are obviously going to align with the process of the creation of a particular regression model. So on the screen here, we can see that we've selected the table level again in the top left, in this case customer. And then we've selected the appropriate modeling type, in this case a logistic regression model with an 80-20 test and learn split. Once we've defined these two elements, we can then move on to selecting our target query, or the other way to think about this is the outcome that we're trying to model. In this example, this is actually being used to find customers who are most likely to purchase a specific GPS device. And we can identify these people that have already made that purchase and use them as a target for this particular model. Now, just as with clustering, we can now define and include our explanatory variables by using our own empirical insight into the data to add in those different variables as we see fit for the construction of this model. Now, in the case of a regression model, rather than looking for commonalities, explanatory variables are selected for use by the model to identify the key characteristics of a GPS customer and how they will actually correlate to the rest of the customer domain. Now, once the model design has been completed, the training process, much as we did with the cluster modeling, will actually run the data and the parameters through the selected model. Now, in this case, we're using R's general linear model implementation of a logistic regression model alongside our predefined parameters. And here we are using the predefined cutting strategy that I mentioned earlier, with 80% of the data used to train the model and 20% used to test the model. And this is allowing us to compare the variables against the target to predict the model's score. And as the model executes, this process repeats several times, derives a score, which is then accompanied by a robustness measure to give us an indication of how robust the model actually is. And as we can see from the page on screen, is that this is presented in the form of a star rating on that commonly used 1 to 5 scale, as well as within a more detailed numerical value. Now, the scoring process produces a value range between 0 and 1, with staged increases in the likelihood up to 1, where 0 means unlikely and 1 means highly likely. And this is these coefficients that we will see on screen here are what we would then look at if we want to actually dig deeper into the scoring and the reviewing of the model process. Now, these coefficients show the variables and the values ranked by order of importance, where importance represents the significance of the variable in the predictive algorithm or within the polynomial. Now, the first value is always going to be 100, and the others are all going to be relative to this. So the first line, the intercept, represents the baseline probability of the model. And the other values shown are standard logistic model statistical outputs that can be used to check the validity of the model. So the estimate is the odds ratio of the explanatory variable, and it acts as a weighting of the particular variable in question. The standard error is the standard deviation from the estimate, and the smaller the error, the more precise the variable predicts the target. The Z value, now this is where the score fits within the normal distribution of results. 0 is the mean, and the positive numbers above average and the negative are below average. The probability helps to decide whether there is a relationship between target variable bought GPS and the explanatory variable or not. The smaller the p-value, the more confident you are about the existence of a relationship between the two variables. The accuracy that we have here, in this example we tested our model against 400 people and we correctly predicted our Boolean outcome only 60% of the time. The confidence in our model implementation is set to a 95% likelihood. So based upon our accuracy, this gives us a 55 to 65% confidence value of a correct prediction using this particular model. So what you're often looking for here is a good spread of variables and ensuring that you haven't used something that's inextricably linked. For example, if you were including taxable income as a database column in predicting customer income, it would almost certainly have a 100% importance, and all other coefficients would have a tiny importance. This would lead to the almost definite creation of a very bad model. So now we can move on to actually look at how we can use models within, in this case, particular regression models, within the different selections, campaigns, and within our different marketing activities. So in the example on screen here, we're sending a communication to all of our customers who have a greater than 80% propensity, as predicted by our model, to purchase the particular GPS device in question. So as you can see, it's incredibly easy to actually incorporate models into a campaign or into a customer journey. Many of our clients choose to do this to help in a number of ways. These include things such as optimizing budgetary spend when utilizing more costly channels such as direct mail, or in other cases, when choosing to deliver a specific experience to customers as part of a wider journey based upon the outputs of a specific model. This could be things such as surfacing particular offers or particular products. But I feel there's a word of caution here as well. So as with all predictive models, when we're using them, we should always be testing on a small set of data and trying these out on a small subset of our customers before releasing them into the complete world of all of our customer data right across our activities. So I wanted to take pause here and revisit our original questions. And if we do so, we can see that predictive analytics provides us with different ways to understand our customers in terms of their behaviors and align these dynamically recalculating segments to our specific marketing tactics. We can also use predictive analytics to make predictions about customers' future behavior based upon how customers with similar attributes and who've exhibited similar behaviors have actually interacted with our brand historically. Now, these outputs and predictions can then be used to proactively inform the experience that we deliver at different points within the customer journey. And as we've gone through today's webinar, I know some of this has been quite statistical heavy. I hope I've shown you how you don't need to be an expert in statistics to be fluent in the complexities of utilizing predictive modeling, and have to have knowledge of query languages to be able to utilize models in your day-to-day activities. But saying that, I also hope that I've demonstrated through the use of BlueVenn how you can actually work more closely with statisticians or data scientists to actually assess and validate any work that you do in this area as part of an iterative and repeatable approach to predictive analytics, especially where that level of collaboration is required as you are starting to get up to speed with deploying predictive modeling for the first time. And in terms of achievements as well, predictive analytics can help us to become more targeted, increase our understanding of customers, whilst empowering our ability to actually deliver the most appropriate experiences for our customers as part of their highly personalized customer journey. So just a few tips in summary then, because I can see we've had quite a few questions coming in, and I know that we've got quite a few we want to potentially get through. The first thing that I want to bring up here is that we need to be ensuring that we have a clearly defined goal so that you can test that a model works. And this is particularly important when you actually begin your journey into the realm of predictive analytics. We need to follow those data preparation steps that I spoke about earlier incredibly diligently to ensure that your analytics are as robust as they possibly can be, while at the same time acknowledging that a single model is unlikely to actually solve all of the different marketing aspirations that you have. So consider using several different predictive techniques concurrently to actually drive the outcomes that you're looking for. And as with most things, it's better to start simple and start small and refine the process and build out over time. And to be sure of a great outcome, I would highly advocate going through a test and learn process to actually build out your own confidence in the results of your predictive analytics as you begin to roll them out across the marketing organization. So Jen, like I said, I noticed we've had quite a few questions come in. Are we ready to take a look at some of those?
Yeah, of course, let's dive in. Okay. So Matt, first question. Once our modelling has launched, how do we maintain accuracy over time?
And that's a really good question, actually. So there are many different approaches to use here. But I would say that things such as regular monitoring and benchmarking of a model's performance are the key ways to effectively manage the health of your models and the outputs that they're providing. So it's difficult because obviously the specifics will naturally depend upon the different methods you're using and the data that you're working with. So if anyone has any particular questions about the data they're using, please do feel free to get in touch and I'd be happy to have that one-to-one conversation as well.
Awesome, thanks for sending that question through to us. The next one that came up was, how would you suggest we start the transition to a more statistical marketing approach?
First things first, start small and iterate. That's absolutely the first thing I would say. But before you even do that, it's about understanding your data and the actual desired outcomes that you're looking to deliver through the use of predictive analytics. And then once you've done that, I would actually say assessing your organization's ability to actually use statistical tools and, where appropriate, gain access to tools such as BlueVenn that place the power of modeling in the hands of marketers and remove that reliance on those data scientists or the highly technical, highly valuable resource within the business as well. And like I said, just remember it's an iterative process that you're going to have to combine multiple methods to help you reach your goals more often than not. But initially, I'd actually advocate starting with recency, frequency, and value. And that's what that's going to do is help you to actually align your tactics with your customer segments. And then once you have started to use that RFV in more detail, you can then start to bring in the other forms of modelling to influence the actual customer experience that you're delivering.
Great. And lastly, please can we have some examples of how best to apply these modelling results to our customer journey?
Wow, that's a really great question, but that's such a broad one as well.
Yeah.
There are so many ways to actually include models as part of a journey that are sort of data and organizational dependent. But like I said during the presentation, optimizing things such as budget spend. I've seen a lot of our customers have used this to enable them to work out whether they should be using so-called cheaper channels such as digital communications channels, email, for example, instead of sort of highly personalized, but also potentially sort of highly costly channels such as direct mail, and using those in the right way for the right customers who are going to respond to those particular channels. But also, we have other customers who've used these to actually offer content and different actual offers and discounts and experiences based upon customers' propensities to engage or behave in particular ways. But again, that main one for me would be all about actually beginning with aligning segments to tactics and then using the approaches like regression to further enhance the experience you're providing based upon that sort of subset that is originally surfaced by those RFV models.
Perfect. Thank you very much for sending those questions through to us. So just before we go, if you haven't already, I just wanted to point out that I have included our Predictive Analytics ebook as an attachment, and you can download that now if you wish. Or you could head to our website, www.blueven.com, and we've got tons more resources there, including more webinars, ebooks, and case studies, etc. And lastly, predictive modeling is just one function of the BlueVen customer data platform. If you'd like to learn more, then you can head to blueven.com and watch one of our weekly demonstrations, or alternatively sign up for a one-to-one demonstration with one of our consultants. So thank you very much for joining this session. I hope you found it beneficial, and we hope to be speaking with you soon. Have a lovely day. Goodbye.